Okay, the first one is a real simple problem. We have a location on the horizontal axis. It's 72, and we want to know the probability of being to the left of there. That's the way we interpret fraction of the population. In other words, you kind of restated it as what is the probability that if you select a person at random, that person will have height less than 72 inches. And the only difference here is that we have a non-standard normal distribution. And it used to be that what you'd have to do is create what we call a z-score and then go to the table in the back of the book. But now we have p-norm, and p-norm will basically take care of that housekeeping chore for you. You just say, I'm not talking about a standard normal distribution where you'd assume the default value of the mean of 0 and the default value of the standard deviation is 1. I'll give you the actual values of the mean and the standard deviation. Okay, so let's run that and let's see what happens. And what it says is that 85% of your people will have height less than 72 inches. Okay, well 85 doesn't sound like maybe that's being a little tough on the tall people in our population, so maybe we should rethink that. And you might ask, well, what's the probability, or what's the height of doors so that only 5% of the people would have to bend over? So again, this time you're talking about a probability, so you know you want to use the Q-norm function. But remember that we want a probability to the left to be using a Q-norm function. But that's easy. We've got the probability to the right is 0.05, so we can get the probability to the left by just calculating 1 minus 0.05. That's obvious, that's 0.95, but I want to remind you that you can actually ask R to do the arithmetic within the call to the Q-norm function. And as before, you supply the actual value of the mean and the actual value of the standard deviation. And let's run that. So it says what you'd have to do is make the doors 73.4, basically 73.45 inches tall in order to avoid having anybody but the top 5% bend over. The idea of a z-score is still very important, and I want to just remind you this is the z-score corresponding to a value of 72. It's 72 minus 69.5 divided by 24. And what this will tell us, it'll tell us how many standard deviations 72 inches is above the mean. So let's just run that and see what it gives us. And of course, as always, when you create something in R, it's not automatically displayed. So I have to ask to see it, Z72. And it says that what you're talking about, 72 inches is 1.04 standard deviations above the mean of 69.5.